presenter today, Izzy Brand.
All right, so we have a lot to cover and not a lot of time. I apologize if this moves quickly, but I'm going to do my best. So today we're going to talk about drones. Now, I happen to really not like the word drone. And you might be surprised because, I introduced my presentation by saying drones. Well, there's a very good reason for that. I think the word catches people's attention quite well. In late 2013, Amazon's delivery drone hit the news hard. Since then, drones have been populating the news left and right. Recently, you've heard about several drone crashes on the White House lawns, and even more recently, a drone graffiti artist vandalized a billboard in New York City. Now, this was really a guy who just duct taped the spray paint can to his quadcopter. But of course, we get a title like the Age of Drone Vandalism. So clearly, the media is picking up on the power of this word as well. And I think a really good example of that is this title here. If I told you there was a model airplane spotted near a local elementary school, you might not think much of it. I mean, probably just some kid flying around having fun. Now, if I told you there was a drone spotted near a local elementary school, now we have a problem. Are these kids in danger? Who's flying this? Are they spying? What's this for? So clearly, the word drone is quite powerful. And there are several reasons for that, I believe. The two primary ones being fear and curiosity. So the fear is pretty straightforward. This is also a drone. And these are dangerous machines. People are aware of their killing capabilities. And so if this is called a drone, and a model airplane can be called a drone, is the model airplane unsafe? The other aspect of fear is the spying. These UAVs can carry cameras, and these cameras can give you perspectives that were once not available. And what that means is now you can see what people previously considered private. This has a lot of people scared as well. But the other important aspect of this technology and why the word drone is so important is because people are curious. I mean, this looks pretty weird. It looks pretty cool, looks futuristic, and it's flying. I mean, that's awesome. And there's one more important part about curiosity. The technology has a lot of applications. In a survey I gave to 260 students all over the nation, these were the things that people thought UAVs could be applied to. Now, I'll highlight a couple. Delivery is extremely important. In areas that are lacking in infrastructure, this technology can be used to deliver medical services like medicine or vaccines where they couldn't previously get it before. I'll also highlight reporting. So often when you want to report on traffic, you have to hire a helicopter. That's no longer the case. You can now send up a quadcopter with a camera, do it much more quickly and much more safely without risking human lives. And thirdly, I'll highlight farming. So what you're looking at here is a picture of a plane flying over crops. So this aircraft is flying a circuit, which is essentially a grid over the crops. And at points along this grid, it's taking pictures of the ground. On the ground, all these pictures can be stitched together to create a high-resolution aerial map of this farmland. Now, what this farmer can do once he has this high-resolution picture is that he can identify areas which need water, which need to be harvested, or which require pesticides or other special treatment. This means the farming can be much more effective and produce much higher crop yields at a lower cost. What's even more amazing about this is that this aircraft costs under $1,000. Now, what the farmer can do with this aircraft is anytime he wants, he can generate a high-resolution aerial image of his farm. For $1,000, that's 1 hour of helicopter time, almost exactly. So you can probably see which he's going to choose. So Congress also realized the potential of this technology. And back in 2012, they created something called the FAA Modernization and Reform Act. And this basically told the FAA, you know what, guys? It's been a while. You need to step up your game and start regulating this new technology. We expect it's going to hit the scenes pretty large, and we need something to happen. So the FAA said, OK, we're on it. But in the meantime, while we're making these rules, let's just say all commercial flights of UAVs are illegal. Also, we're not going to allow anybody to use a live video stream to control the aircraft. So if you're going to be flying the aircraft, you need to have visual contact with it. So in 2013, a man named Raphael Perker flew what is arguably one of the most important drone flights of all time. And yes, this flight happened to break both of those rules. He was getting paid by the University of Virginia to fly a promotional video. He also used FPV, which stands for first person view, to transmit the video back to himself to pilot the aircraft. Now, the University of Virginia was hiring him to do this, and he also had police cooperation. The police were clearing the streets to make sure that he didn't hit anyone. Of course, once the FAA saw this video, they hit him with a big fat fine. He was endangering people and property. Now, in the past, that had happened to several pilots, and they just paid up, or the case kind of faded away. Parker did something different. He hired a lawyer, he fought it, and amazingly, he won. The judge ruled that small unmanned aerial vehicles are actually not aircraft, and for this reason, the FAA has no authority to regulate them. So now this means that, the skies are open. Anybody can do whatever they want, and it was great. The industry boomed. However, the FAA went and got their bigger brother, the National Transit Safety Board, and the NTSB appealed the case, and it was turned over. Parker was indeed fined. So now the regulation is back in place, and once again, drones are illegal for the most part. And that regulation stands to this day. So it is illegal to fly a drone for compensation, and it's also illegal to use an FPV system to fly your drone. There are case-by-case exceptions. It's possible that if your company has a proven safe aircraft, you can get certified to fly. This certification process takes a long time. And what this means is by the time an aircraft has been certified, it's already obsolete. The technology is old. Now this is a problem, okay? Because this new technology and the new markets that are building around this technology stand to generate $13.6 billion within the next 3 years in the United States. Now, within the next 10 years, that number balloons to $82 billion and over 100,000 jobs generated within the United States alone. Now, if the FAA is preventing people from flying, then we won't stand to benefit from this economic impact. And the technology will move overseas to China, where it's already taken a huge footing. So I happen to work at one of these quasi-illegal drone companies called Above Summit, based in Somerville. And what we do, is we offer aerial photography services. Basically, everything we do is, for the most part, illegal, but yes. Interestingly, we have the support of the local governments. So this particular footage here is taken over a school building, or not a school building, a public building in Somerville, and we're looking at snow buildup on the roofs. So we had a lot of snow this winter, as you all know, and the city of Somerville was worried that some of this weight of the snow could cause roofs to collapse into this building. So rather than hire a fireman to go up and fly there, they hired us, and we went up and we took pictures, and they were able to assess the situation. Now this story actually made national news, because here was a case of a city government supporting us in something that the federal government banned. Of course, nothing ended up happening, which is good, because that would have lost my job. But it's just an interesting story of clearly the technology has applications and people are ready to use it. It's just the federal government is not ready to regulate it. So if you ever need any aerial photography services, definitely hit us up and we'll get that covered. So let's talk about how I got this job. So I've always been interested in flying. About 2 years ago, I really got into the hobby of flying model aircraft. And right from the get-go, I was interested in flying as high as possible. What this meant was, I would often fly up until I could no longer see the thing, and then I would lose it. Or maybe I would lose radio contact, and then I would lose it. So about a year into the hobby, I discovered autopilots. And what this essentially allows you to do is use a GPS, a gyroscope, and an accelerometer to control the plane and have it fly by itself. And this is really cool, because now I can program the plane to fly to a specific GPS location, and it'll go there. This particular image that you're looking at right here is taken exactly 1 kilometer above the Tiger of Newton North High School, looking out over Boston with one of these planes. So 1 kilometer is cool. By the time the plane got back down, the battery's basically dead. And I thought, 1 kilometer is not that high when you think about actual airplanes. I want to go higher than that. So what do? Well, we take a weather balloon. You use a weather balloon to lift the airplane all the way up to the edge of space at nearly 100,000 feet. Then the plane disconnects from the weather balloon and glides back down from 100,000 feet to land at a target landing point, in this case, Burr Elementary School. So plane goes up, disconnects, and glides back down. At no point in this trip does it ever have a motor, because it just uses the potential energy from 100,000 feet to get all the way back down. Now, I thought this was kind of a fun experiment. It turns out it has real-world applications. People often send scientific payloads up to the edge of the atmosphere to do things like monitor wind speeds or pressure or chemicals. Now, for the most part, when the payload disconnects from the balloon, it just kind of falls and smacks down to the Earth, and they have to go find it. And usually it's a 10-mile radius. With the GPS, it gets a little bit closer, but still, it's very difficult to find. Turns out NASA has similar ideas. NASA is working on a project called Spqr, for Small Payload Quick Return. What they want to do here is essentially take materials that are on the International Space Station and return them to the ground without the use of a space shuttle, because obviously the space shuttle no longer exists, unfortunately. So they essentially developed a parachute that would go on the payload, and you can change the shape of the parachute to steer the device as it's falling. And what this would allow astronauts to do is essentially toss something out the airlock, and a couple days later it would land at Kennedy Space Center. They, unfortunately, were not having a lot of success in this endeavor, and the two photos you can see behind me are actually the parachutes collapsing and failing in the upper atmosphere. And I was like, well, a plane's not going to collapse, so maybe I stand a better chance than NASA. If I can beat NASA, that'd be awesome. So now I really have to pursue this project. So I got right to work. I knew that I wanted to do an iterative design process, and what that means is I was going to build several prototypes, test them, take the good from one, and eliminate the bad, and keep on going. Before I even thought about it, I decided I wanted to use a flying wing type of airframe. Conventional aircraft, like the ones you usually fly in, are pretty good, but they're much less efficient. They can't carry nearly as much weight, and they're not as simple, which means that they are more likely to fail. So all of the planes I'm going to build are going to be flying wings. Now, again, before I can start building, I have to generate a computer model. So I went and took care of that, and I built the flying wing, and this has a roughly 46-inch wingspan. And then it was time to start building. Now, it's kind of hard to choose materials that you're going to send to space because it's really, really cold, and there's really low pressure. I ended up choosing a material called XPS, or extruded polystyrene. You may know it as insulation foam. It's pretty much available at Home Depot. It's a really good material. It's quite stiff. It's got good insulation properties. It won't fail at low temperatures or low pressures. But what's really bad about it is you basically can't cut it with a knife, like most styrofoams. So to cut it, we have to use something called a hot wire foam cutter. And this essentially just heats up a piece of string, or a wire rather, until it's hot enough to just melt the foam as you're cutting it. So here you can see I'm working on the fuselage, and then use the hot wire foam cutter to cut out the wings out of the same material, glue everything together. In the next photo, I've installed the winglets. Those are the things on the end of the wings, the white pieces, and that will keep the plane steady in flight. I've also cut out sections of the back of the wings. This is where the control surface is going to go. The control surface is kind of like the flaps you might see on the wing of a regular like Boeing 747. This will allow the plane to direct the way it's flying. Up next was installing the electronics. What you're looking at now, that blue thing in the bottom, is called a servo. It's a little motor, and what it allows me to do is set the position of the control surface to direct the plane in flight. Now typically, I would just mount the servo out on the wing of the airplane. Can't really do that in this application. And the reason is because the servo's got grease inside of it, so it'll freeze. That means I have to put the servo inside of the fuselage of the airplane somehow, and then route the mechanical energy out to the control surface. My solution to that was a curved wire guided through 3D printed, essentially little loops. And you can see that there. That's kind of unique among model airplanes. So I got everything set up, and I put a motor on the back, and I named it the ARV for Autonomous Return Vehicle Mark I. Now, the reason it has a motor on the back, even though it's a glider, is because I don't really have a way to get it up to altitude without using a balloon. And balloons are expensive. So for testing, it's going to fly up on the motor, chop the throttle, and glide back down. So awesome. Brought it out in the field. Time to test. I won't make you watch the whole thing. Needless to say, it flew very well, and I was quite happy with it. So I brought it home, and it was time to install the autopilot. The above photo shows before, and the below photo shows after. You can see the autopilot made it significantly more complicated. This ended up being a problem, a big problem. So the balloon failed, and I don't know exactly the cause, or not the balloon, the plane failed. I don't know exactly the cause, but my theory is that it was trying to travel to GPS coordinates that were below the surface of the Earth. So it just kind of flew right into the ground. That was that. It's OK. I know how to build planes. Building another one. Back to the catting. There were several things I wanted to change from the prototype. Back to the building. You can see I've reduced the size of the fuselage. The bottom one is the Mark I fuselage. The second one is the Mark II fuselage. And I also modified the control surfaces. On the first prototype, I used a tape hinge. Essentially, this relies on the flexibility of the tape to allow the control surface to move. The problem with this is tape has got adhesive on it, and the adhesive will freeze in -40°C. So the hinge is going to get stuck, or it's going to crack off. For that reason, I had to use regular mechanical hinges like this. Put everything together, and we were good to go. Once again, so again, I was pretty happy with this. Brought it home. I installed the autopilot, and then this happened. So that was the Mark II. Here's the Mark III. So, Mark III. Fairly similar to the first two prototypes, I increased the wingspan by 4 inches to improve the glide slope. And I also modified the internals of the fuselage. Now, in the previous two fuselages, it was just an open space where I'd throw in all the stuff. Here, it's kind of cut out like a camera case, where all the electronics kind of socket to a very precise area in the foam. This helps with the thermal retention and also makes the fuselage stronger. Now, you can see here that I've still got a motor on the back. Once I was happy with the way this was flying, it was time to get rid of that motor. But I still needed some way of getting it up into the sky to test it. So fortunately, my friend and I had recently built a giant cargo plane. You can see him posing with that here. So I decided we were going to use this giant plane to lift up the smaller plane and drop it. So that was cool. Put the plane on, get it all set up. The way we were going to do this is I was going to control the little plane, and my friend was going to fly the big plane. And he was going to release the little plane, and I was going to fly it back down. Now, for the first couple of tests, I was going to fly it in manual mode, just to make sure everything's working. And then once it was all good, I was going to put it in autopilot mode. So what you're seeing here is that plane, and we clicked the detach button, and nothing happened. So at this point, I'm freaking out. I put the transmitter down for the little plane and take the transmitter for the big plane. Then it falls off. So nobody's manning the controls at this point. I'm flying the big plane. The little plane is spiraling to the ground. And yeah, that's the third one. Now, this was the evening before I had planned the launch. I had selected the launch date based on the weather. It needs to have very low wind speeds and also very clear. So I spent the day that I was supposed to be doing the launch rebuilding this aircraft. Fortunately, the next day, which is by now Tuesday of this week, was not terrible weather. It was raining pretty hard in the morning, but by the afternoon, we had a couple of hours to play around with. Unfortunately, what this meant is that I wasn't able to launch to the full altitude. Launching up to the full altitude would require around 90 minutes to ascend and nearly 4 to 5 hours to descend. I didn't have that amount of time before it got dark, so I decided to launch up to 23,000 feet. So we picked a location. It ended up being in Worcester, Massachusetts, and I had a team of volunteers. Thank you guys very much. We all headed out and got set up. First things first, rolling out the plastic sheeting. The balloon is very delicate, so it can't touch the grass. So this is brand new plastic sheeting. You can see everybody's using gloves to inflate the balloon. If you touch the balloon, the oils on your hand will damage it. So it can't be handled with regular hands. Balloon got bigger, and bigger, and bigger. And once it was generating around 6 pounds of lift, it was time to do the launch. So we had picked this kind of inconspicuous field out in middle Massachusetts. And we were there for around 15 minutes setting up, completely abandoned. Then we hear a bunch of screaming. Look over to a nearby building, and hundreds of elementary school kids are pouring out of the building. And we're like, oh God, this is really bad. Fortunately, they all stayed in a playground, which was behind a fence, but they were kind of yelling at us during the launch. So we were really worried about that. But it was OK. Got everything set up, attached the plane to the balloon, and time to let go. Here we go, boys. So now you can hear all the kids screaming. You can hear all the kids screaming in the background. That was, yeah. Unfortunately, I couldn't stay to watch my several $100 aircraft float up into the sky because now it was a race to get back to Burr to retrieve the aircraft. So quickly stuffed everything back in the car, jumped on the highway, headed out really quickly. We beat it by about 15 minutes to Burr. This is the flight path that the airplane was expected to take. You can see that kind of red, explodey thing in the middle is where the plane would detach from the balloon. And from that point, the autopilot would take over and fly back to Newton. So we were going to recover at Burr Elementary School. Fortunately, we beat it by about 15 minutes to the target landing site. Unfortunately, half an hour later, nothing showed up. So it's a good thing I put a GPS tracker in there. Let's figure out what's going on. Turns out the plane was in Framingham. Close. We went out to investigate, and it turns out the plane was in Framingham and 40 or maybe like 65 feet up in a tree. It was way up there. We threw rocks at it for about 45 minutes, called the fire department. They said, tough luck, like whatever. So next day, we come back armed and ready to get this thing down. Here you can see Luke using a potato cannon to try to shoot the plane. It's up there in the tree. Unfortunately, to no avail. The plane, as of this morning, was still up in the tree. Now, what this means is I can't really tell you much about what went wrong. Fortunately, when I got close enough, I was able to establish radio contact with the plane up in the tree and download some of the rough flight data. What I found is that the plane had successfully reached the target altitude of 23,000 feet and had successfully detached from the balloon and switched into autopilot mode. Unfortunately, at some point during the descent, it failed and landed about 6 miles, or closer to 7 miles away from the target landing point after traveling 22 miles. So I would call this flight, a partial success. The balloon went up, which is a big, that's a good thing. The plane detached, it's a good thing. At some point on the way down, it didn't make it. It got 22 miles out of a total of 28 to the target landing site, but unfortunately it didn't quite make it. Now this is just, this is usual in testing. And that's why this is not my last prototype. I'd like to introduce you to the ARV Mark IV. I will be launching this again some point later this year. And I have it right here. So thank you very much. All right.